Okay, here we go. Process capability. I'm going to go ahead and review accuracy and precision with the standard deviation and normal distributions. So we're going to run back to our dartboards. All right, so here's our target. The closer we are to center, we're saying the more accurate we are to the measurement. That's terrible drawing, but oh well, we're going with it. So there's our dartboards. We'll say that this is accuracy. We'll have a, how do I want to label this? We'll do accuracy is high, and we'll do precision is high. Here we go. So we'll do both good at first. So here's our darts. So they land around the center. They stay close together. That's high accuracy, high precision. Let's come over here. Let's do high accuracy, low precision. Now, this definition of accuracy only works when we're averaging multiple measurements, because if we take the average of these, we're close to the target, but we're not very precise. We're scattered around. So this is the idea that I've got, I'm making pins for something, like pin shaped like this. One of them's twice the diameter it's supposed to be. One of them's half the diameter it's supposed to be. Well, on average, I'm doing great. I'm spot on. But I've got such terrible precision that we have problems. So this is high accuracy on average, but precision is low. Here we'll do low accuracy, high precision, something like that. So I'm off target on everything, but I'm consistently off target. And then finally we've got, what if they're all bad? Okay, it's going to be something like this. So scattered, but all off to one side in terms of the range. So accuracy and precision are low. Okay, there we go. So I hope that works. Hope that's readable. Let's go to our idea of the normal distribution. So we've got a centering or an average for our X bar and R charts. This would be an X double bar. This would be our process average, or this may be called the mean if we're working with the whole population. Here we've designated what do plus and minus 1 sigma, 2 sigma, 3 sigma look like, and here's roughly the percent of our data that we should include, assuming an actual normal distribution, whether it's plus minus 1 sigma, 2 sigma, or 3 sigma. And 3 sigma pretty much includes everything. Less than 1% generally is outside of 3 sigma. So what does that look like for our accuracy and precision situation, though? Okay, so let's see how we're going to do this. It's probably going to be hard to do. We're just going to come over here and remember what that looks like, okay? So with high accuracy and high precision, both of them high, we should have a very narrow distribution, and our average, so our x bar, and our, I'll call it target, our intended dimension, are very close together or um, indistinguishable from each other. So what happens when we've got high accuracy, low precision? Now we're accurate, so our average and our target should be close. They should be close together. But now our distribution is going to be much more flat and spread out. So we're making, that's not the greatest drawing, but it's okay. So on average, we're accurate, but we're spread out in terms of our distribution with a high standard deviation. Notice that your minus 3 sigma plus 3 sigma on a graph that's essentially the same size as the one over here, they're a lot more further apart on the bottom axis. Right, so we've got this distance over here. See, these are much more spread out. So that means high standard deviation, low precision. Okay. What about our other case where we've got low accuracy but high precision? Our curve is shifted to the side, where now our average and our target are far apart, but we've got a low standard deviation. So standard deviation doesn't tell us anything about our accuracy, it just tells us something about our precision. What happens when everything's bad? We get a big flat curve off to the side, where there's our actual process average, and there's our target, and we've got a high standard deviation. So that is relating accuracy and precision back to the normal distributions. We'll need to remember and think about this stuff for today when we talk about process capabilities. So I think I'll go ahead and stop this one here just so the review is on its own, and then I'll jump into notes about process capabilities.